Hey, what's up guys? So today we're going to talk about this cheaty bank Python coded challenge, which is about using a proxy or a bridge to create an API that's going to simplify another API. Basically, we're dealing with this bank, which has a third-party API, which is a third-party API, which is very unreliable. And our goal is to make it more reliable for our own client. So let's look at the requirements. So you're a startup, you're dealing with this bank, they have an API, okay? And what we want is that our clients want to just give two IBANs and just have the money being transferred. IBAN from the initial bank account and IBAN from the bank account that's going to receive the money, and bam, the transaction has to just happen like this. Unfortunately, it's not that easy with our banking API, and our job is to make it easier. This is the backend of the bank API, the shitty bank API, and we're going to take a look at that in a minute. Here are some information about the different endpoints. Okay, and here we can see that sometimes instead of performing a requested task, an endpoint will just return result success, but in fact, nothing is actually done. This happens around 20% of the time. Sometimes random requests will cause a breakage of the entire system for an extended period of time. In that period, every request will not only return error 500, it will also extend the failure period by a constant amount. So not only does the app break, but if you don't notice and you keep trying, it's just going to keep breaking, because each time we redo a request, it extends it breaks the system even more basically. And this happens 2% of the time. Well, basically the information that we get right now is that we have to make the least amount of requests possible, and that whatever the API is returning doesn't even mean anything. It could return result success without being a success, and it could just break. And whether this happens 20% of the time or 2% of the time doesn't really matter in my opinion, because at the end of the day, we're just dealing with an API we're dealing with an API with which we should try to do the lowest amount of requests possible, and for which we cannot trust the answer, the responses. So we're going to have to implement our own mechanism to test if our settlements are being handled properly. There's a parameter called time factor to accelerate the times for testing purposes. And this is what we want to send to our API, from IBAN to IBAN amount period. And what this is supposed to do is to create two wallets here. Okay. Two virtual wallets. I don't know where it's written anymore, but there we go. Create virtual accounts wallets for your customers to pay. Okay. These are additional information. We also want some robustness, meaning that the server, the third-party API doesn't have a database. So everything is running on the instance. So if the service is killed, all the events or whatever wallets that have been created will be deleted. But we cannot allow that to happen on our database. So we will have to have our own database, and we're going to have to store the information on our side. Okay? So let's make this happen. For this, we have created this Django project. We chose Django REST framework because this is a small project. This could have been done maybe with Fast API, but usually within the fintech industry, I would say that Django REST framework is the standard, and that's the reason why I chose to use Django REST framework. So we have our CoolBank project, and there's the core project here, and the CoolBank API app here. Let's take a look at our models. We have created two models, a wallet model with just an ID and an IBAN. And the reason for that model is that, again, we'll take a look at the shitty bank API backend, but there are no ways from their side, there's no relationship between an IBAN and a wallet. So you can potentially create two different wallets with different IDs for the same IBAN, which of course doesn't make sense in real life. So we're going to use that to track the relationship between our wallet IDs and our IBANs. After that, we have the settlements, which are basically payment transfers. And we have two types, paying or payout. Paying if money is about to enter in the account. Payout is when money is about to leave the account. And then we have status choices, which is here. And the status is, because as we said, we can only try to make settlements, but then it could be a failure or it could be successful, depending on the mood of the third-party API. So we're going to track the status as well. Other than that, we are going to make a relationship between the settlement and the wallet using that foreign key. The type, as we said, pay in or payout, the amount of money, the IBAN, the date at which it has been created, and also the event ID, which is related to that settlement, because we're going to be using events to track if the settlements have been processed accordingly. Let's take a look at our serializers. Here, there's nothing fancy. For the wallet serializer, we're just using model serializer, which is a powerful serializer, which is going to use our model and all the fields of our model to create that serializer and create some validations. But for settlement serializer, we're using custom field because, again, we don't really want to be using all these fields. We just want to be imputing from, to, an amount. And now let's move to the views, which is going to be the most interesting part of this project. Okay, so we basically have this class, settlement API view, and we initialize it. We use the super method to initialize the API view over there, but we're going to customize it and add a base URL, which is going to be the URL of our Citibank backend application, which is Flask application, which is just over there. We're going to take a look at it after. After that, so that's a post request, right? And the post request is just basically going to validate the serializer and execute the transfer money method. And we use from, to, and amount, okay? If the serializer's data are okay, we return 201, meaning it's been created successfully. Otherwise, we return 400. Now let's take a look at our first method. Pretty simple, transfer money. We just create two settlements. First settlement is about paying the receiving account, and the second one is about taking money from the account that's paying, basically. And this is according to the requirements, which asks that first we credit the account, and second we take money from the other one. After that, we're going to create a custom get or create wallet. And the reason why we are using that custom method is to have a relationship between a wallet ID and an IBAN. Basically, we want to be doing this because when we're creating a wallet, we want to know if this wallet, if there's already a wallet like that related to that IBAN. And that's what we're doing here. And after that, we are using this post request to /wallet to ask the API to create this wallet. Now, there's something tricky with this endpoint, because if we go into the Citibank backend and we look at /settle, which one is it again? Oh, no, sorry, /wallet. Okay, there we go. Create wallet. See, if the wallet already exists, meaning they already know the ID of the wallet, it's going to return an error. If it doesn't exist, it's going to say success. The problem is that, as we said, we cannot trust any of these endpoints. There is no way to know. After we do this, there's no way to know if the wallet was actually created. So we're going to have to redo that each time, because basically either it's already there and it's not going to do anything, or it's not there and it's going to create it. And we return these two things. So basically, if it's the first time we're creating that wallet, create it's going to be 1. If it's that's how get or create works, right? If it's the first time we're creating the wallet, it's actually creating it in our database, and create is going to be true or 1. And if it already exists, it's going to be 0. And we will need that for later. Now, let's move to the next step. So we have create settlement. Okay. Now we have our wallet created, and we need to create this settlement. And we're going to use that get or create method we've just defined. Again, we are we're taking the wallet, and we want to know if it's a new wallet or not. That's going to be useful for what we're going to do right after. Here we have a bunch of data, wallet ID, type, IBAN amount, which is the data we're going to send to the post endpoint to our Citibank API in order to create a settlement. Here's just some JSON conversion, etc. Over here, and this is why we need this created. It's because, well, actually, no, we don't need that created here. I think this was for another version. This could be removed. Actually, what's going to happen is that this is happening here. Created in DB. Create in DB. So if we want to use that create in DB parameter, basically we specify to that function that we want to create the settlement in our database. That's going to create a settlement in our database. And the reason why we want to specify that is for when we're going to implement a recheck mechanism a bit later in the code. By default, this is true, meaning when we create a settlement, if we don't specify anything, we're going to create that settlement in our database on top of trying to tell the backend of our third-party API to create it also. So over there, we create our settlement, and by default, it's failed. Then our recheck mechanism is going to go through the event and try to figure out if there's an event associated with that settlement. And if that's the case, the status is going to change. So that's our create settlement method. Okay, so that's it for the views. Now, after these settlements have been created, we need to implement a recheck mechanism because, as I said, no communication with that third-party API can be trusted because it's so messed up. So let's see what we've created there. We've created this task, create settlement, which is a Celery task. Here's the way it works. We have a global variable called Citibank API with the status and a timestamp. When we enter that check settlement task, we're going to make sure that the status is not crashed. If it is crashed, we're going to look at the timestamp. And we're going to try to figure out if it has crashed since more or less than 60 minutes. Because that's the time when the app crashes, it crashes for, it stays offline for 60 minutes. And we don't want to be making any more requests during this time because, as described in the requirements, more requests mean that it extends the amount of time during which the app is crashing. So if it's crashed and that it's been less than 16 minutes, API crashed less than an hour ago. If it's been more, then let's put it back to working. Okay, we are going to create this instance of the settlement API view. And here we're going to basically add some information to the logging info because I like to see what's happening when some automated task is running. First thing we're going to do is we're going to try to find some failed settlements in our database. If there are no settlements which are failed, then no failed settlements, let's just return. There's nothing to do here. Now, if there are some failed settlements, we are logging them. And then we're going to go through the events using that endpoint. And notice the last event ID here because we're going to track, so we're going to have a bunch of events with different IDs. And we're going to track where we are in that event list so that we don't have to check all the events each time. We know that before that ID, we have already processed these events. So the only events that are interesting right now are the events after the last event ID that has been checked. And this is going to be changing dynamically. So we're going to look through our settlements. And then for each settlement, we're going to look through the events. And we're going to make a bunch of verifications right now. Does the event have the same wallet ID? Yes. Does the event have the same wallet ID? Yes. Does the event have the same event ID? Yes as well. Then it means that we found an event. And the reason why we have this double verification is that we could have two different events, two different transactions, which come from the same wallet. So we need to make sure that this event hasn't been consumed already. Otherwise, we could just have one event associated with one wallet, and using that function would consider that every settlement associated with that wallet actually happened. So we have to make sure that the settlements, it matches for as far as the wallet is concerned and as far as the event ID is concerned. So if we find an event with the same wallet ID and the same, and sorry, here's actually we want to make sure that we didn't go through that event yet. So we want to make sure that the settlement event ID is different from the event ID we're processing right now. Okay, if we find such an event, we're logging it, and then we're changing the settlement status to successful. After that, we're changing the settlement's event ID, and we're just saving it. And we're changing the last event ID so that we won't have to process any event that has been processed already. Okay? Otherwise, settlement not processed, retrying. And not processed, meaning that that settlement was created in our database, but it hasn't been processed by the third-party API. Otherwise, we would have found an event. So we're going to try to retry. So we're going to call that function again, create settlement, but here notice the false parameter, because these are settlements that are already created in our database. So we want to create them in the third-party API, but we don't want to create them anymore in our own database, which is why we have here create in DB, which is now being specified as false. Now what happens is that sometimes we said that the app is going to crash. If the app is going to crash, here we're going to have a JSON decode error because it's actually going to return an exception. We're going to take a look at the third-party API in a minute, but it's going to return an exception, so that's going to trigger that kind of error. And we're just going to assume that if this happens, it means that, well, the Citibank API has crashed. So let's change the status. Now the status is crashed, and we're going to give it a timestamp. Okay? So that's how the Celery task is working. Cool. Let's take a look at the Citibank API backend. So how does it work? Here we have a bunch of variables, error rate, fit probability, time factor, which are basically going to be used here in this decorator, which I completely commented it during my first iteration of the code because it was impossible to test. So here's the function that's going to make things fail. And notice that this API function decorator is being applied to every different endpoint, meaning that no matter what we're trying to do, either create a wallet or retrieve some events or create a settlement, anything can fail, right? Anything can fail because of that decorator. Of course, the reason why this decorator is there in a real API would not exist is to simulate an unreliable API, which do exist. Here we have the get event function, which is going to return us the different events with the beginning of the list being the minimum ID that we give. Here we can create a wallet. And by the way, notice something. So when we create a wallet, this is an interesting part of the code. When we create a wallet, we're going to add to the wallets dictionary the ID of that new wallet, and we're going to give it an integer. So what's this integer? Well, actually, if you look at the code a little bit below, you'll notice this part. That number is going to be used like an amount. That's going to be the amount of money that's on the wallet. The problem is when you create a new wallet, by definition, well, not by definition, but the way the code is made, is that when you create a wallet, it's gonna create a wallet with zero amount. And therefore, that part of the code is gonna crash. It's gonna fail because the wallet has no money, and we're trying to take money out of it. Well, I'm sorry, let's be more clear. If we're trying to create a wallet to make a payout, it's gonna crash because of that part of the code. So here, I took the liberty to just comment that line for a very simple reason. I figured out that we could create a mechanism where, say that we need to create a new wallet for a client for a payout. That new wallet is going to come with zero money. Or we can just create a settlement and artificially give that wallet some money. But then, what would that mean? That would mean that this customer would kind of owe the bank or the software or whoever that amount of money that's being automatically credited in order to allow it to make these payouts. So why not just comment out that line, so that what's going to happen when we comment that line is that we're going to have wallets with negative amount. And I think it's a good way to say, well, this is the amount of money that you owe. Now, obviously, if this API was real, we would have these wallets that should normally pre-exist, or we would have mechanism to create settlements to give them money, to credit them before we do the payout. But right now, the way the requirements are made is saying this. The bank provides an API to create virtual accounts for your customers. And they don't specifically say, how are we supposed to credit an account before transferring the money? We just give two IBANs, and the money has to go from IBAN 1 to IBAN 2. But we have no information about how this account is supposed to be credited. So again, I could have used a different strategy, such as creating a settlement to credit that initial account for the payout. But I feel that's weird. And in a way, if we do that, then the customers still owe money to someone. There's some kind of, we would know that, for example, all wallets are created with $5,000, and now there's 4,000 left. So the guy actually owes $1,000 to the bank or whatever. And I think it makes just more sense to comment it because therefore we have negative amounts, and it just makes more sense. But other strategy could have been applied. So basically, there's just a mechanism to make sure that when we're trying to take money out of an account, this account has enough money. So it makes sense. But for the project, it doesn't really make sense in my humble opinion. Cool. So let's go back to how these wallets are created, right? So yeah, we basically settled this. And here is the settlement function. Notice that here's something that's something a bit weird. We assert that amount is a string, but then we want to convert it to an str. So for example, if like me, you have here in your models a decimal field for amount. The reason why I put decimal field is because usually amount of money are, well, decimals. They're not integers because we're dealing with, you could be like $20.25. So usually decimal make more sense. The problem with that is that in the serializer, if I input $1,000, it's going to send the data as 1000.00. And even if here it's going to be okay because you can turn that into an str, it will not be able to turn 1000.00 into an integer. Okay? And this is why here we have some kind of double conversion. First, we turn it into an integer so that it removes the 0.00. And after that, we turn it back into an str. And then there's the whole conversion. Okay? Let's go back with our code, our Shitty backend. There we go. Wallet not found, whatever. So in the end, none of this matter, because if it fails, we have our recheck mechanism that's going to recheck every now and then to make sure that the transactions are being processed accordingly. Cool. Get events. Here we have the so that's the broken function that's going to basically completely crash the app, and it can happen at any time. Okay, cool. This is how the events are being added. So we're using a DQ. We are and again, there's some element of randomness here happening. Okay, now let's see how this works live. Cool. So let's try to use, for example, Postman to create a settlement. So we have our database here. Okay, these are the settlements, as you can see here. For now, it's empty, and the wallet empty as well. We're just going to use the example that was given in the documentation. I've just copy-pasted it in my code here, and let's make a post request. Well, first, let's just completely restart every different server and stuff like that. So I'm going to kill the Django server, kill the backend, kill my Celery worker, and kill my Celery bit. So we can really start fresh. Let's run the Django server again. Third-party API, my worker, and my Celery bit. Okay. Now we're gonna do this post request in order to create a transaction. There we go. Let's see what happened in our database. Now we have our wallets, which have been created with their respective IBAN, and our transactions. Now notice that the transaction is already successful because the event have been processed already, because I've set it up to verify the event every 5 seconds. Obviously, this could be changed to every 5 minutes. But if I create another transaction and I look at my database very fast, it's created initially as failed and with no event ID. But if I wait a little bit and I refresh the database, now it's successful. And it found an event related to that settlement, and it added it as in the event ID column. And we can see this happening here. Okay, sending task due every 5 seconds, Celery worker, and see here we can see the different logging, checking settlements, no failed settlements. Obviously, every 5 seconds is a little bit too much. We might want to change that. See, this is where it happened. Checking settlement, 2 failed settlements found event. They even it's even logging when I've added the logging to know exactly what was being processed right there, and then settlement not processed, retrying, etc. Okay. We can look also maybe at the, not sure if that's really useful for the project, but this is how the Celery configuration is set up. So we have installed Redis as a message broker and Celery to deal with the periodic tasks. And here is our schedule and our task. That's it. I hope that you enjoyed. Just a quick note. So I didn't work on that at all during the weekend. So that's the work of yesterday night. And today, during the day when I had time between, my actual work. There's probably multiple ways we could improve that, but I'm getting a bit of pressure from the recruiter to finish the task as fast as possible. And again, I didn't work on it on the weekend, so obviously this is like a couple of hours of work, and hopefully that's going to be good enough. Cheers.